The photograph sits in a Luftwaffe intelligence folder, dated August 1942. Grainy, shot from 23,000 feet over East Anglia. The analyst notation reads, Bauweise unbekannt, construction type unknown. Penciled arrows point to 18 identical rectangular structures, arranged in neat rows beside a runway that hadn't existed 3 weeks earlier. The shapes don't match anything in the recognition manuals, not the curved roofs of British Nissen huts, not the peaked silhouettes of Romney shelters, something new. The German photo interpreter was looking at the Pacific Hut, a design that had existed for exactly 73 days. Tracking American construction in Britain drove Wehrmacht intelligence officers slowly insane. The bases didn't grow, they appeared. One reconnaissance pass showed farmland. The next showed a functioning airfield with hangars, mess halls, barracks, and taxiways capable of handling 4-engine bombers. The British had been building airfields since 1939. The Americans matched 3 years of British construction in their first summer. The Luftwaffe's construction analysts had filed detailed reports on every British temporary structure type. They knew the Nissen hut, that corrugated steel half-cylinder the British had invented in 1916 and never improved. They knew the Romney, the lying, the handcraft. Each had distinctive shadows, distinctive spacing requirements, distinctive assembly timelines. A trained analyst could estimate a base's operational readiness by counting roof types and measuring construction progress between sorties. Then, the Americans arrived, and the math stopped working. I'm still digging into what happened next, what the Americans actually built, and why it mattered. If you want to see where this goes, hit subscribe. Like the video if this approach to the story is working for you. And if you know something about Pacific huts that belongs in this script, comments are open. A Luftwaffe reconnaissance assessment from late 1942 noted with evident frustration that American facilities appeared to reach operational status before German analysts could even catalog the structures. The report used the phrase industrial construction tempo, their attempt to describe something they'd never encountered. British bases took months, Soviet bases took longer, American bases took weeks, sometimes days for certain building types. The Germans weren't imagining things, they were watching something unprecedented. A military that had figured out how to make buildings the same way Henry Ford made cars. What confused the photo interpreters wasn't just speed, it was uniformity. British bases showed variety, different hut types mixed together, structures added over time, layouts that evolved organically based on what materials happened to arrive. The photographs looked like villages that had grown. American bases looked stamped from a template, identical spacing, identical orientation, identical buildings repeated dozens of times. The reconnaissance officers had never seen military construction that looked mass-produced because nobody had ever mass-produced military construction at this scale. The specific structure driving them crazy was a simple wooden rectangle, 20 feet wide, 48 feet long, with a shallow pitched roof, walls of prefabricated panels, the Pacific Hut, named not for the Pacific Theater, but for the Pacific Coast Borax Company's engineering team in Los Angeles, who had designed it from scratch in 1942, when the Army realized its existing hut designs couldn't keep pace with mobilization. The British Nissen hut, the design the entire Commonwealth had standardized on, required curved corrugated steel sheets that had to be manufactured at specialized rolling mills. Steel was rationed. The mills were bombed. Each Nissen took trained workers to erect properly. The semicircular shape wasted floor space and couldn't be expanded. Heating was inefficient. But the British kept building them anyway, because the design existed, and the tooling existed, and changing meant stopping. The Americans looked at the problem differently. The Pacific Hut used no steel except nails. The panels were wooden, pressed fiber or plywood, materials available from any lumber mill in North America. 5 unskilled men could erect one in under 4 hours, using nothing but hammers. The panels were sized to fit standard truck beds. The design was modular. Bolt 2 Pacific Huts, end to end for a longer building. Bolt them side by side for a wider one. More importantly, the Americans published the blueprints openly. Any carpenter could build one. Any factory could cut the panels. The bottleneck wasn't specialized production. It was shipping. And America had more cargo capacity crossing the Atlantic than anyone in history. German intelligence eventually identified the Pacific Hut in their recognition manuals, filing it under American temporary structures alongside the Quonset, another design they'd never seen before, 1942. But identification didn't solve their analytical problem. Knowing what the buildings were didn't explain how they appeared so fast. The construction timelines they calculated based on British experience were off by factors of 3 or 4. Their estimates of base completion dates were worthless. 1/8th Air Force Base, Deboche, in Suffolk, went from cow pasture to fully operational bomber station in 4 months. The construction crews worked around the clock. Prefabricated components arrived by truck convoy. Buildings went up so fast that paved roads sometimes came after the hangars they were supposed to serve. The reconnaissance photographs kept coming. More unknown structures, more impossible timelines. The Luftwaffe analysts weren't stupid. They understood they were watching American industrial methods applied to construction. What they couldn't grasp was the scale of the system producing it. The smell was the first thing. Wet canvas, mildew, and the particular funk of 30 men who hadn't bathed in weeks. Lieutenant Colonel Peter Nissen walked through the tent lines behind Ypres in the spring of 1916 and understood why the British Expeditionary Force was losing men to sickness almost as fast as it was losing them to shellfire. Canvas rotted in the Belgian rain. Wooden tent poles splintered under shrapnel. The floors were mud, not muddy, but actual liquid mud that sucked at boots and bred disease. Men slept on duckboards laid over the slop, wrapped in blankets that never dried. Nissen was a mining engineer from Ontario who joined up at 45 years old because he thought his experience building remote camps might prove useful. He was right. What Nissen designed in the following weeks was born from desperation, not vision. The Western Front needed structures that exhausted soldiers could erect with minimal tools. They had to fit on narrow-gauge railways and be cheap enough to abandon when the lines shifted. His solution was a half-cylinder of corrugated steel sheets bolted to curved ribs with wooden end walls. The curve shed rain and resisted blast pressure. The corrugated sheets were self-supporting, no internal framing required. A crew of 4 could assemble one in under 3 hours once they learned the sequence. The structure weighed about 1.5 tons, light enough to move on a single lorry. The British Army loved it. By the armistice, they'd built over 100,000 Nissen huts across France and Belgium. The design won Nissen a knighthood. It also won him nothing else. The patent was assigned to the crown, and he saw no royalties. But that's beside the point. What matters is what happened after 1918. The Nissen hut was designed as a disposable shelter for a war everyone assumed would end. When the war did end, the surviving huts were sold off as surplus or left to rust in French fields. The design files went into storage. The specialized jigs for bending the curved steel ribs were scrapped or repurposed. Britain demobilized everything, including its institutional knowledge of rapid construction. The assumption was reasonable. There would be no next war requiring such desperate measures. 21 years later, Britain discovered it had been wrong about everything except the hut. When war came again in 1939, the Air Ministry faced an immediate problem. Fighter Command needed dispersed airfields, dozens of them, scattered across southern England, each requiring barracks, mess halls, workshops, and headquarters buildings. The obvious solution was to revive the Nissen design. It had worked before. Men still alive remembered building them. The curves still shed rain. But reviving a 23-year-old design proved harder than anyone expected. The original manufacturers had gone out of business or converted to other products. The steel rolling mills that had produced corrugated sheets in the right gauge and curve were now making ship plates and tank armor. The wooden end wall templates had long since rotted or burned. Engineers had to reverse engineer the specifications from surviving examples, measuring rusty huts in farmers' fields with calipers and tape measures, then working backward to produce new blueprints. The French had faced something similar in the 30s, actually. When they started building the Maginot Line's rear installations, they'd tried to revive their own temporary shelter designs from the previous war and found the same institutional amnesia. The drawings existed, but the manufacturing base had evaporated. They ended up designing new structures from scratch, which took years. The British, pressed for time and bombing already underway, chose the faster path. Just rebuild what they'd had before. Inefficiencies and all. Anyway, the revived Nissen hut entered production in 1940 with all its original limitations intact. The curved steel sheets still required specialized rolling mills now competing for steel allocation with tanks, ships, aircraft, and 100 other priorities. Each hut consumed approximately 2,000 pounds of steel, a material Britain was importing across submarine-infested waters. The semicircular cross-section still wasted nearly 30% of its footprint to unusable space near the curved walls. Bunks couldn't sit flush against the sides. Equipment couldn't stack to full height. Heating systems fought the geometry. Hot air rose to the peak, while cold air pooled where men actually slept. The War Office knew all this. Internal memoranda from 1940 and 41 complained about the Nissen's inefficiency in surprisingly blunt language. One quartermaster's assessment calculated that housing the same number of men in rectangular structures would require 40% less material and 50% less shipping volume. Another noted that the skilled labor required to erect Nissen huts properly was exactly the labor most needed elsewhere: metalworkers, riggers, construction supervisors. But Britain in 1940 had no time for redesign. The Luftwaffe was bombing every night. Invasion seemed imminent. The choice wasn't between the Nissen hut and something better. It was between the Nissen hut and nothing. So the mills kept rolling curved steel. The trains kept hauling components. The construction crews kept bolting together a design that had been adequate for temporary use in 1916 and was now being asked to house the force that would win or lose the war. The Americans, arriving in 1942, took one look at this situation and asked a question the British apparently hadn't. What if we just started over? January 23, 1941. The contract lands on desks at the George A. Fuller Company in New York. Attached specifications run 11 pages. The Navy wants a prefabricated shelter suitable for tropical and Arctic deployment, capable of withstanding 100-mile-per-hour winds, erectable by untrained personnel in a single day, transportable by standard military vehicles, and manufacturable using materials not currently allocated to combat equipment. Delivery of working prototypes, 60 days. The Fuller engineers stared at those 11 pages and saw the Nissen hut's ghost in every requirement. The Navy had studied the British design carefully. Too carefully, perhaps. The semicircular arch appealed to them because it was structurally efficient and shed wind loads without creating the turbulence that ripped roofs off rectangular buildings. The curved shape required no internal posts or columns to obstruct the floor. The corrugated steel skin needed no separate structural frame. What they didn't like was everything else. Fuller's team set up shop at the Navy's new Construction Battalion Training Center in Rhode Island, a patch of shoreline called Quonset Point that would give the resulting structure its name. The engineers worked in a converted warehouse that smelled of sawdust and machine oil, surrounded by stacks of rejected prototypes and arguing constantly about load calculations. They had the Nissen's blueprints spread across drafting tables, marking problems in red pencil. The list grew longer every day. Curved corrugated sheets required expensive rolling equipment. The wooden end walls rotted in tropical humidity and cracked in Arctic cold. The floor sat directly on ground, meaning moisture wicked up through everything. Insulation was an afterthought. Blankets stuffed between the outer skin and an inner liner, if anyone bothered. Heating ducts couldn't follow the curved walls efficiently. Electrical conduit had to be run exposed, where it caught on equipment and clothing. The breakthrough came from thinking about the problem backward. The Nissen design started with the arch and forced everything else to accommodate it. The Fuller engineers started with the manufacturing constraint. What could American factories actually produce in volume? And worked forward to a shape that happened to be an arch. Steel was tight, but not impossible. The Navy had allocation priority that the British didn't. The question was, what kind of steel, formed how, by whom? Curved corrugated sheets needed specialized rolling mills. Flat sheets could come from anywhere. So they flattened the curve, not into a rectangle, which would lose the structural efficiency, but into a series of flat segments that approximated an arch. The Quonset hut's cross-section looks like a half-cylinder only from a distance. Up close, it's a polygon, 8 or 12 flat panels meeting at shallow angles to form a curve. Each panel could be stamped from flat stock on standard presses. No specialized tooling required. The ribs changed too. Nissen ribs were curved steel tubes that had to be bent to precise radii. Quonset ribs were T-section steel formed straight, then bolted together at angles matching the panel joints. The curve emerged from assembly, not manufacturing. A factory making filing cabinets could produce Quonset components without retooling. But the real innovation was in what went inside the skin. The Nissen was a shell, corrugated steel and air. The Quonset was a sandwich. Between the outer steel panels and an inner liner of pressed board went layers of insulation, rock wool or fiberglass batts, depending on availability. The floor sat on steel sill sections that held it above ground level, creating a dead air space that blocked moisture migration. Electrical conduit ran in channels pressed into the inner liner. Heating ducts mounted flush against the walls instead of hanging from the ceiling. This was a complete building system, not just a roof shape. The prototypes went up at Quonset Point through February 1941, each iteration fixing problems revealed by the previous one. The construction crews were deliberately chosen for inexperience. The Navy wanted to know if recruits fresh from farms and factories could actually build these things. They could. The modular design meant each task was simple, even if the total structure was complex. Bolt this panel to that rib. Repeat. No welding, no precision fitting, no specialized skills. A 12-man crew assembled the standard 20-foot by 48-foot model in a single shift. The Navy accepted the design on March 22, 1941. 58 days from contract to approval. Production contracts went out immediately to manufacturers across the country. By Pearl Harbor, Quonset huts were already shipping to Atlantic bases. By mid-1942, factories were producing them at a rate of nearly 1,000 per week. The numbers tell part of the story. A Quonset hut required about 700 pounds of steel compared to the Nissen's 2,000. It packed into smaller shipping containers because the flat panels nested efficiently. A ship that carried 40 Nissen huts could carry 60 Quonsets. Assembly time dropped from 3 hours with a skilled crew to 4 hours with men who'd never seen the design before. The floor space was fully usable because the walls met the floor at right angles, not curves. But the numbers miss what mattered most to the men who actually lived in these things. The insulation worked. In the Aleutians, where temperatures dropped to 40 below and winds screamed across treeless islands, Quonset huts stayed warm with a single oil stove. In New Guinea, where humidity rotted canvas overnight and insects invaded everything, the sealed construction kept the jungle out. The floors were dry, the walls didn't sweat, the electrical systems didn't short in the first rainstorm. The Navy had asked for a better Nissen hut and gotten something else entirely. An industrialized construction system designed from the ground up for mass production by the world's largest manufacturing economy. The engineering mattered less than the paperwork. Every Quonset hut shipped with a single folded instruction sheet, 1 page, printed on both sides, laminated against moisture. The sheet showed 12 sequential diagrams with minimal text. A man who couldn't read English could follow the pictures. A man who'd never held a wrench could identify which bolt went where, because each fastener type was drawn at actual size with a silhouette he could match against the hardware in his hand. The Navy's technical writers had studied how Ford trained assembly line workers who spoke a dozen different languages, and they'd borrowed the same principle. If the instructions require explanation, the instructions have failed. The British approach to technical documentation assumed competent tradesmen supervised by experienced foremen. The American approach assumed nobody knew anything, and nobody was coming to help. Operational reality demanded nothing less. The Seabee construction battalions landing on Pacific Islands in 1942 and 43 included farm boys from Kansas, factory workers from Detroit, and fishermen from Louisiana. They had 6 weeks of basic training. They stepped off landing craft into surf, still pink with blood from the assault waves, dragging crates of prefabricated buildings behind them, while Japanese snipers worked the tree line. There would be no telephone call to the manufacturer, no consultation with the engineering department, no waiting for the specialist to arrive on the next convoy. The instruction sheet was the specialist. The lamination was a detail that revealed the thinking behind everything else. Paper dissolved in the Pacific, salt spray, monsoon rain, sweat from hands that hadn't been dry in weeks. Ordinary documentation turned to pulp within hours of leaving the shipping crate. The Navy's Bureau of Yards and Docks tested 11 different coating materials before settling on a cellulose acetate laminate that could survive 3 months of tropical exposure. They tested it by burying sample sheets in compost heaps and leaving them in steam rooms and dragging them through surf zones behind landing craft. The sheets that survived became the standard. A Seabee on Guadalcanal in late 1942 could drop his instruction sheet in a mud puddle, fish it out, wipe it on his dungarees, and keep working. The same couldn't be said for the Japanese construction manuals captured on the island, beautifully printed technical drawings that fell apart when touched by wet fingers. The lamination cost an additional 3 cents per sheet. Multiplied across hundreds of thousands of huts, someone in Washington had to approve that expense. Someone did. The file documenting that decision has not survived, but the laminated sheets did, some of them still readable 80 years later in museum collections. The acetate yellowed, but the diagrams still clear. The tools required for assembly fit in a single canvas bag weighing 11 pounds, 2 socket wrenches in different sizes, a claw hammer, a hand drill with 3-bit sizes, tin snips for trimming flashing, a level, a chalk line. That was everything. No welding equipment, no pneumatic tools, no generators to power them. The Nissen hut required a portable forge to heat rivets and trained riveters to drive them. The Quonset used bolts throughout, slower than riveting, technically, but infinitely more forgiving. A man who cross-threaded a bolt could back it out and try again. A man who botched a rivet had to drill it out and start over, assuming he had spare rivets, which he often didn't. The bolt inventory for a standard Quonset included 20% overage built into every kit. You'd lose some in the sand, drop some in the dark, strip a few learning the torque pattern. The kit assumed waste because the designers understood that exhausted men under fire made mistakes, and the system had to absorb those mistakes without failing. The most telling detail was the foundation options. The instruction sheet showed 4 different base configurations depending on what the ground offered. Concrete footings, if you had cement and time. Wooden sleepers, if you had lumber and less time. Steel sill plates directly on compacted earth, if you had neither. Sandbag perimeter walls, if you were still taking mortar fire and needed something standing before nightfall. Each option used the same superstructure, bolted to different anchor points. The Nissen hut required a level concrete pad, or a precisely graded wooden platform. Deviations of more than ½ an inch caused the curved panels to bind and leak. The Quonset's segmented arch tolerated imperfection. The panels flexed slightly. The bolt holes were slotted rather than round, allowing adjustment during assembly. A structure that went up crooked could be straightened by loosening bolts, kicking walls into alignment, and retightening. This wasn't elegant engineering. It was engineering for a world where elegance got men killed. The British designers of 1916 had created a structure that skilled soldiers could erect under difficult conditions. The American designers of 1941 had created a structure that unskilled sailors could erect under impossible conditions. The difference wasn't technical sophistication. The Quonset was arguably cruder than the Nissen in pure engineering terms. The difference was assumptions. The British assumed their system would mostly work and built in corrections for when it didn't. The Americans assumed their system would constantly fail and built in redundancy so that failure didn't matter. Every Quonset that went up on a Pacific beach proved both assumptions correct. 170,000. That's the final production count for Quonset huts by August 1945. A number so large it loses meaning until you start breaking it down. Roughly 47 huts completed every single day for 4 years. Enough floor space to cover Manhattan below 14th Street. Enough steel to build 3 Iowa-class battleships, except the huts housed the men who built and crewed those battleships, which made the arithmetic circular in ways that pleased the War Production Board enormously. The factories turning out these components sprawled across 23 states. A stamping plant in Ohio pressed roof panels. A lumber mill in Oregon cut the interior framing. A hardware manufacturer in Connecticut boxed the fasteners. The pieces converged at coastal depots, where longshoremen loaded them onto Liberty ships that fanned across every ocean to every climate where American forces needed shelter. The Aleutians got their shipments through fog so thick that cargo nets swung blindly from crane to deck, stevedores working by sound and feel because visibility dropped to arm's length. Guadalcanal received huts while the airfield was still under nightly bombardment. Crates stacked in dispersal revetments, open between raids, components hauled to building sites in darkness. North Africa, Sicily, England, India, China, Australia, 100 islands whose names Americans had never heard before, 1941, and would mostly forget by 1950. The British encounter with all this started quietly. Lend-lease allocations in 1942 included construction materials alongside the tanks and aircraft that got the headlines, and somewhere in the paperwork appeared line items for prefabricated shelters. The first Quonsets arrived at Liverpool docks in the winter of '42, crated and anonymous, routed to RAF stations, being expanded for the American bomber offensive. British ground crews unloaded them alongside their own Nissen components, and for a few weeks, nobody paid much attention. A hut was a hut. Then someone opened a crate and found the instruction sheet. The reaction filtered up through channels slowly, the way institutional embarrassment always does. A stores officer at a Midlands airfield wrote to his regional quartermaster asking why the American shelters included insulation as standard, while British troops were still stuffing newspaper between Nissen skins. The quartermaster forwarded the query to the Air Ministry with a note that reads, even 80 years later, as barely suppressed fury. The American huts, he observed, appeared to have been designed by people who expected human beings to live in them. The Nissen had been designed by people who expected human beings to endure them. A formal assessment followed in early 1943. the kind of bureaucratic document that exists to confirm what everyone already knows, while providing cover for decisions already made. The assessors visited bases, housing both British and American personnel, measuring interior temperatures, documenting condensation levels, interviewing occupants. The Quonsets ran 12 to 15 degrees warmer in winter with the same fuel expenditure. Their floors stayed dry. Their electrical systems didn't short. Men slept through the night instead of waking at 3 in the morning to feed inadequate stoves. The report recommended adopting the American design for all new British construction. The recommendation went nowhere. Tooling changes, production line disruptions, the usual excuses for organizational paralysis. What happened instead was quieter and more damning. British units began requesting lend-lease Quonset specifically, by name, through supply channels never intended for such granular preference. Quartermaster files from 43 and 44 show requisition forms, annotated with handwritten notes, American type preferred, or Quonset if available. The paper trail of men who'd slept cold in Nissens and weren't willing to do it again. Some of the requests were approved, many weren't. The allocation system didn't accommodate preferences, only quantities, but the requests themselves told a story that nobody in Whitehall wanted to hear. British soldiers, given the choice, chose American engineering over their own. Not because of patriotism or politics, because the American version kept them warm and dry, and the British version didn't. The smell inside a well-built Quonset was distinctive. Pressed board liner releasing a faint woody sweetness, machine oil from the heating system, the particular mustiness of wool blankets that had actually dried overnight instead of staying perpetually damp. Men who transferred from Nissen billets noticed it immediately. The absence of mildew, the absence of that cold mineral tang that came from condensation dripping off bare steel, warmth that reached the floor instead of pooling uselessly overhead, light switches that didn't spark, windows that actually sealed. These weren't luxuries. They were the baseline conditions for human habitation that British design had never quite achieved, and American design had insisted upon from the first specification sheet. A Seabees veteran interviewed decades later remembered the Quonset simply as home, the word he used unprompted, 3 times in 10 minutes of conversation. Home on Tarawa and Saipan. Home on Okinawa, where the mud ran red and the rain never stopped, and the only dry place on the island was inside those arched steel walls. The British troops who received Quonsets through lend-lease used different words. They called them the American huts, even after the war, a designation that carried weight long after the manufacturing details faded from memory. What lingered was simpler. The Americans had sent them something better than their own country provided. The men who lived it remembered. The document sits in the National Archives, filed under Foreign Military Studies B-Series, number 734. 16 pages typed on American military paper by a German colonel named Friedrich von der Heydte, dated November 1945. Von der Heydte had commanded a parachute regiment in Normandy, and the Americans wanted to know what he'd seen. The question that produced the most detailed answer wasn't about tactics or equipment or leadership. It was simpler. What surprised you most about the American soldier? Von der Heydte's response runs 4 pages. He circles the answer several times before landing on it, as if reluctant to admit what he'd observed. The American infantry he fought in the hedgerows appeared rested. Not soft, he's careful to make this distinction, but recovered. Men who had slept the previous night. Men whose uniforms were wet from the morning's dew, rather than from 3 continuous days of rain they'd never escaped. Men who had eaten a hot meal within the past 12 hours. His own troops, by the summer of '44, had forgotten what any of that felt like. They slept in holes scraped into Norman clay, covered with whatever they could scavenge, waking every few hours to the shaking cold that preceded dawn. They ate when rations arrived, which was increasingly never. They wore what they'd worn since the invasion began, and nothing dried, and nothing warmed, and the exhaustion accumulated in their bones like sediment. The interrogators pressed him. Surely German logistics had provided shelter. Von der Heydte's answer carries a bitterness that survives translation. The Wehrmacht supply system, he explained, prioritized ammunition and fuel. Everything else was the soldiers' problem to solve. If a unit captured buildings, they slept in buildings. If they held open ground, they slept in the open. The assumption, never stated but always present, was that German soldiers would endure what needed enduring, because they were German soldiers. Endurance was doctrine. It was also, by 1944, killing them faster than American bullets. The medical data tells the rest. Exposed soldiers lose cognitive function measurably within 72 hours of inadequate sleep and warmth. Reaction times slow, judgment degrades, errors compound. A man who hasn't been properly warm in a week stops caring about things that will kill him. He takes risks he wouldn't take rested. He misses movement in his peripheral vision. He fails to check corners, forgets procedures, fires at sounds instead of targets. The German Army Medical Service documented this in reports that went unread by commanders who couldn't spare the resources to fix the problem anyway. Shelter wasn't a combat system. Shelter was comfort, and comfort was weakness, and weakness lost wars. This was the philosophy that froze the Wehrmacht outside Moscow in '41 and would freeze it again in the Ardennes in '44. The Americans had a different philosophy. Shelter was a weapons system. A rested soldier was more lethal. A warm soldier made better decisions, and a dry soldier didn't develop the trench foot that had crippled a quarter of all British casualties in the First World War. Every Quonset hut that went up behind American lines was ammunition for a weapon the Germans never understood: the systematic preservation of human combat effectiveness through infrastructure the enemy considered frivolous. General der Infanterie Gerhard Franz, interrogated in 1946, put it more bluntly. His division had faced Americans in the Hurtgen Forest, that frozen hell where the fighting chewed through battalions like a saw through pine. The American replacements, he observed, arrived at the line in better condition than his veterans who had held it for weeks. They came forward from heated billets, fed from heated kitchens, supplied by a system that seemed to have infinite depth. His own replacements arrived already exhausted from the journey forward, already cold, already hungry, already halfway to the 1,000-yard stare that marked men as combat ineffective. The Americans could rotate units out of the line because they had places to rotate them to. Heated places. Places where a man could sleep without waking to check if his feet had frozen. Franz had no such luxury. His men stayed in the line until they died or broke because there was nowhere else to put them that offered improvement. The Quonset hut never appears in these interrogation transcripts by name. The German officers didn't know what the Americans called their shelters, didn't care about the engineering specifications or the manufacturing philosophy. What they knew was the result. American troops who should have been as wrecked as their own weren't. The infrastructure was invisible to them. 1,000 steel arches scattered across supply depots and airfields and port facilities, housing the men who kept the ammunition moving and the trucks running and the replacements flowing forward. The combat troops cycled back to those arches when they rotated out of the line. They slept on dry floors under insulated roofs and woke without shivering. They ate food that had been kept warm in heated mess facilities. Then they went back to the fighting, and the Germans facing them saw soldiers who had no right to look that fresh, but did anyway. Von der Heide used a phrase in his report that the American translators rendered carefully because it mattered. He said the American system treated its soldiers like capital to be preserved rather than fuel to be burned. The German system assumed unlimited fuel. The American system assumed limited capital and built accordingly. Shelters that kept men functional, logistics that kept men fed, rotation policies that kept men sane. By 44, the fuel was running out on the German side, and the capital on the American side kept compounding. A sergeant from the 29th Division, interviewed 50 years later, remembered coming off the line in November 44 and walking into a Quonset for the first time. He stood in the doorway for a full minute, he said, just feeling the warmth. Warmth that reached the floor. Warmth that didn't demand he feed a stove or huddle with other bodies or wrap himself in everything he owned. Just warmth provided, waiting for him. He slept 14 hours straight. The Americans do not solve problems. They simply overwhelm them. The line appears in a 1943 memorandum from the British Ministry of Works, unsigned, filed among assessments of Allied construction methods. The author meant it as criticism. The Americans, he complained, threw resources at difficulties that British ingenuity had learned to work around. They built new when repair would suffice, replaced when maintenance would extend. Scarcity was a temporary condition to be corrected rather than a permanent reality to be managed. He was describing, without knowing it, the fundamental difference between an empire in decline and one still ascending. The Nissen hut survived 26 years of continuous production because it worked well enough. It kept rain off heads, mostly, provided shelter from wind somewhat. It could be erected by trained men with proper tools in reasonable time under acceptable conditions. For an empire stretched across a quarter of the globe, managing commitments that exceeded resources every single year, well enough was the operating standard. You didn't fix what functioned or replace what held. You didn't waste engineering talent redesigning solved problems when unsolved problems multiplied faster than the staff could track them. The institutional habit of endurance, of making do, of carrying on, had built the empire in the first place. It was also, by 1942, strangling the capacity to imagine alternatives. The Americans arrived with different habits. A problem encountered was a problem to be eliminated, not accommodated. If the existing design leaked, you didn't teach men to position their bunks away from the drip points. You redesigned the roof. Instructions that confused workers got rewritten. You didn't train better workers. A heating system that couldn't warm the floor meant insulating the floor, not issuing extra blankets. This wasn't generosity. It was engineering philosophy applied to human systems, with the same rigor Americans applied to machine systems. Waste in human performance was still waste. Inefficiency in human comfort translated directly to inefficiency in human output. The accountants at the War Production Board understood this arithmetic better than any humanitarian ever could. A soldier too cold to sleep was a soldier too tired to fight, was a soldier who got killed and had to be replaced at a training cost of $11,000 and a transport cost of $800 and an equipment cost of $1,500. The Quonset's insulation paid for itself before the first winter ended. 60 days. That's what it took to move from contract to prototype. Not because American engineers were smarter than British engineers, but because the American system permitted starting over when starting over made sense. The institutional authority to say, "This doesn't work, let's try something else," existed at levels where such decisions could actually be made. Peter Nissen had created his hut as a wartime expedient in 1916. By 1939, it had calcified into doctrine. Changing it required approvals from offices whose entire purpose was preventing change, staffed by men whose careers depended on continuity. The Quonset emerged from a system that assumed the first answer was probably wrong and built revision into the process. Otto Brandenberger and his team at Quonset Point produced their design, knowing it would be criticized, modified, improved, and eventually replaced by something better still. They designed for iteration. The Nissen had been designed for permanence, and permanence had trapped it. The Luftwaffe photograph from August 1942 sits in a folder in Freiburg now, transferred from captured German records after the war. The analyst's typed notes remain clipped to the back, his careful count of structures, his estimate of construction rates, his flag for superior review. Someone above him wrote a single line in pencil, barely legible after 80 years. Tempo beachten. Watch the tempo. He'd seen what mattered. Not the huts themselves, corrugated steel arches, unremarkable from 23,000 feet. What mattered was the speed. Structures that hadn't existed on Monday stood complete by Friday. Bases that held 100 men in June held 1,000 by September. The production capacity behind those numbers exceeded anything Germany could match, and the analyst knew it, and his superiors knew it, and the knowledge changed nothing, because knowing a problem exists is not the same as being able to solve it. The Germans watched the tempo. They could not match it. The British watched too, from closer range, with more complicated feelings. Their own huts stood beside the American ones on shared airfields. Same function, same purpose, different assumptions about what soldiers deserved. The men who transferred from Nissens to Quonsets didn't need reports or studies to understand the difference. They felt it in the warmth that reached their feet, heard it in the silence of electrical systems that didn't spark. They smelled it in blankets that had actually dried. Some of those men are still alive. A few of the huts are too, scattered across England and the Pacific, repurposed as storage sheds and agricultural buildings. The pressboard liners long rotted, but the steel arches holding. One stands on private land near Duxford, converted to a workshop in 1947, still heated by a system that runs on the original oil-fired principle. The owner found the instruction sheet in 1983, folded inside a wall cavity, where some Seabee or Army engineer had tucked it 60 years before. Laminated, readable, 12 diagrams showing exactly how the building he'd inherited had come together in the first place, drawn for men who'd never held a wrench, in a country that assumed problems existed to be solved.